The networking break was obviously successful because there's a lot of good discussions going on, and hopefully everybody enjoyed the round tables. Had three really excellent sets of folks at my table, so I hope everybody enjoyed that experience very much. Well, we're going to move into, we've got a series of 3 presentations leading up to lunch. And the first, we're going to discuss SNCR for Fleetwide compliance. A case study is going to be presented by Kevin Dougherty. Kevin is the Vice President for Business Development and Marketing at Fuel Tech Incorporated, which is located about 30 miles west of here in Warrenville, Illinois. Kevin has 25 years of experience in air control systems, 13 years with Fuel Tech Incorporated. So we're going to learn a lot about SNCR technology. So Kevin, want to come on up?
Okay, how do I get the shifted onto the screen, I guess is the question. There it is. Thank you. Well, I appreciate the opportunity to come and talk a little bit today about a case study that we had done. I'm going to go ahead and show you who's involved in that. This is a joint case study we did, Fuel Tech, Midwest Generation, and also Sergeant Lundy. This was a couple of year project that we worked on with Midwest Generation and with support from Sergeant Lundy and Gray Corps in terms of SNCR being applied to their fleet. And we'll talk a little bit about what their requirements were in terms of Midwest Generation, technology options and evaluations that they went through. I'll give you an overview of SNCR technology. We'll talk a little bit about how the team worked together in terms of the teaming and project approach. Talk about the scope, schedule, some of the equipment details, kind of what the challenges we experienced through the project, and kind of let you know current status. To give you a quick overview, the Combined Pollutant Standard was a 2006 agreement that Midwest Gen made with the state of Illinois in terms of a multi-pollutant arrangement. Mercury controls, I'm not going to really touch on that too much, but July 2009 was their compliance date, and they were in compliance at that time. For NOx, they were looking to go for a January 2012 compliance starting date with a fleet-wide average of 0.11. And I'll get into a little bit of what their baseline situation was and where they were coming from and what it took to meet that average. Just as a side note, the other element of that is SO2 compliance. With January 2013, the initial start date, kind of stepping down from a 0.44 down to a 0.11 by 2019. Over the last month or so, they've more or less adjusted some of that ramping as it relates to some of those interim year requirements on their SO2 side. We're going to focus on NOx. If you look at Midwest Gen relative to their fleet, they had equipped everything with low NOx burners, predominantly burning PRB coal. When you look at the fleet-wide baseline of level for emissions, somewhere in the 0.2 to 0.25 range, they looked at various options to meet their NOx targets, and one of the key things they started out with was, well, what about if we just install SCR on the big flagship units, which is essentially the units at Powerton. Then there was also the possibility of some induct SCR on some of the bigger units. And then they went through the consideration of SNCR technology and rich reagent injection, and I'll talk a little bit about that in a minute, as an alternative to see could that be a potentially lower capital cost option for them to get into compliance. And then, of course, the unfavorable option consideration of looking at a potential D rate. Just briefly, I'll touch base on just the technology in general. A lot of you are familiar with it. SNCR technology, basically in-furnace urea or ammonia injection. Ammonia is typically not applied to a utility unit due to the distribution and the temperature window requirements. It's just not very effective, but ammonia can be applied on industrial and smaller units. You're typically looking at a 1600 to 2200 degree temperature range that you're trying to get that process reaction to take place in. Multiple level system essentially to chase that temperature window, so we can go from 100% MCR down to 25%, depends on what the customer typically wants. Most of the time you're looking, depending upon baseline and particular geometries and temperatures, 20 to 30% is typical for what NOx reduction can be achieved. And at $5 to $20 a kW, that's typical of a total installed price. Rich reagent injection is kind of an add-on to SNCR, and it's specific for cyclone units. We did do some testing to see if the rich reagent could be applied and get to essentially the low oxygen zones on wall and T-fired units, but at this point in time, it works very well on cyclone units, and you're looking at another 30% NOx reduction. So on a combined basis, SNCR with RRI, you're looking at a 40 to 60% capability in terms of reduction. You're injecting, with RRI, you're injecting urea in substoichiometric conditions, and essentially you're burning out with the orifire air over the top once you come out of the cyclone barrels and achieving some very good NOx reductions. The one benefit is it's got a higher NSR. When we say that normalized stoichiometric ratio, that's about the ratio of nitrogen compounds to NOx. It's probably twice that of an SNCR system. But it is extremely effective and a little bit higher operating costs, but you're not dealing with any ammonia slip as any sort of byproduct from the system with RRI. SNCR, we deal with ammonia slip all the time, and we're well skilled at avoiding those kinds of issues. And this technology was licensed by Fuel Tech from REI, it's Reaction Engineering International, and EPRI. When you look at SNCR, as I mentioned, the temperature window that you're trying to affect the reduction, ultimately, if you could operate at the top part of the curve, you could completely maximize your NOx reduction. But what you run into at the top of the curve is you get into situations where you cannot quite control your ammonia slip. As you kind of come down on the curve, typically the most favorable thing to do, unless you're looking to generate more ammonia slip, is to go onto the right side of the curve. So you're injecting a little bit hotter than your optimum process temperature. And when you do that, you're able to affect the NOx reduction and control the ammonia slip and do that in such a way that you can establish what your guarantee requirements are and keep that unit in compliance and away from any operational problems. One thing to really consider as it relates to SNCR, and it happened with Midwest Gen as well, the impact of CO on the SNCR process is pretty significant. If you were to look at, let's say, the 2,000 degree line there kind of up and down, you can see that with increasing levels of CO as you go to the turquoise curve, essentially your NOx reduction performance starts to suffer significantly. So as a result of that, good combustion ahead of the SNCR process is extremely helpful and required. And sometimes you get into situations with SNCR following in after a low NOx burner. They've cranked those burners down to the point where there's not much NOx coming out of them, but CO may be an issue for you. So we have a lot of times to do the balancing act of detuning burners and kind of improving the reaction potential for SNCR to get an overall reduction, but you kind of stay away from pushing those burners too hard. The other effect of CO is that it will effectively push the reaction temperature window that you're trying to get SNCR to happen in. It's going to push it into a cooler zone. And typically that's not good because you're pushing it into superheater and reheater tube bundles, and that's typically not where you want to have that reaction happen. This is a 3D model. We do a lot of visualization of various boiler geometries, and you can kind of look at the temperature surfaces there between 1950 on the red and 1750 on the blue, and you can see with 150 ppm of CO, you're kind of around the bullnose. You've got some that doesn't look like a lot of room. That's a lot of room for an SNCR reaction to take place. When you look at a 500 ppm CO, what that does to your temperature window, you've pushed your allowable zone into a very small space and then back up into those superheat bundles. So that becomes a problem, and as a result, that's something that had to be considered when applying the technology downstream of low NOx burner technology. This is just a very simple schematic from an SNCR system perspective. You have a FRP storage tank. That's essentially fiberglass. You can do field-erected steel tanks, which actually Midwest Gen did for a couple of their units. Dilution water pressure control and a HFD module. Essentially, you're going to circulate the urea and feed that to the injector zone metering module, the IZM. And essentially, then you're going to have mixed and dilute chemical that's going to go to the distribution modules and then the individual injectors. As you kind of consider working with urea solutions for SNCR, one of the things you have to think about is what's going to be your source of dilution water. Typically, you're starting with 50% solution, and we're generally going down to 5 to 10% concentration at the point of injection. It helps for distribution, and it helps minimize the operating costs. But there obviously is some additional dilution water required. Site-by-site requirements on dilution water may push you towards using boiler demon quality water, or you can use regular service water if you have some if you use the right additives put into the urea solution, essentially help things keep from scaling. Midwest Gen, based upon their units and sizes, went ahead and made the investment and went with higher quality dilution water requirements through putting RO and softeners in on the various plants. This is just a slide to kind of talk about the fact that Fuel Tech, we're very well versed in urea supply, unstabilized urea. We are not a urea supplier. First of all, let me clarify that. There's been a lot of misconceptions even over the many years that, well, if you're buying their SNCR system, you got to buy the reagent. That's not how it goes. We do have some additives that we provide to reagent suppliers that will help people use regular service water for use with their system if that's the route they chose to go. In the case of Midwest Gen, they went with unstabilized urea, and that was the choice they made. Over the long period, it's probably the better solution in terms of economics to go with the unstabilized urea and treat the water at the site. As you go through the SNCR injection process, we have a couple of different options in terms of injection. These are two different types of wall injectors that we use. We also have something called a multiple nozzle lance, which actually cantilevers inside the unit, can get us in between the superheater tubes, and essentially get the reaction to be affected in those small, very tight environments. That was not a requirement for any of the Midwest Gen facilities. The HERT injector is a high-energy reagent technology, and essentially it's a mechanically atomized injector with carrier air, and essentially you're going to get very good localized NOx reduction around the point of injection. That kind of in combination with our traditional NOx-out injector, that allows a NOx-out injector is an air atomized injector, which allows us to vary the air pressure and change the droplet size so we can get a kind of a spread of distribution, so that we can essentially put bigger droplets in and let those droplets evaporate and essentially inject maybe 2,500 degrees in some cases, and let that water evaporate, and then essentially put us in the position to have the chemical react in the proper zone, and that probably 1900 to 2100 degree is more the optimal zone. So that flexibility allows us to get good coverage with a HERT injector right at the point of injection, but also penetrate it further into the unit in terms of into the center and push that reaction downstream. So the combination of those allowed us to really look at some really positive results as it relates to Midwest Gen. In 2009, March, April, we did some actual demonstrations to determine achievable performance. T-fired units, we did Will County 3 and Crawford 8 and showed some very significant reductions. Joliet 6 and Powerton 51, the combination of SNCR and RRI also was very promising. So what that led to was Fuel Tech doing a fleet-wide proposal and evaluation for Midwest Generation with budget prices and performance evaluations. And then essentially kind of from that budgetary position then to develop commercial guarantees. We did that by actually collecting some specific boiler temperature and species data and do that site data collection so that we could establish a final equipment design and injector configurations, all the utility requirements, and then establish the firm guarantee position. And we did that in December 2009. And as Midwest Gen was going through the evaluation of what they were going to do, they were capital constrained. That was really their big issue that kind of pushed them away from looking at SCR on Powerton. And I'll talk a little bit about the end relative to what that cost comparison looked like in terms of capital investment. But as Midwest Gen kind of looked at how they were going to do this within their fleet, they worked with Fuel Tech. We worked together to come up with an alliance agreement arrangement. Essentially, it's a system-wide pricing agreement, and it gives opportunity for savings across multiple units, allows the teams to continue to work together, really starts to build on the efficiencies, and creates an environment where we can share cost savings. And Midwest Gen already had an existing arrangement with Gray Corp Sargent & Lundy in terms of their engineer and construction aspect, and they worked with different technology providers and some other areas. And Fuel Tech kind of came part of this overall team. So as we look at the teaming arrangement between the three, I'll talk a little bit about some of the scope splits that were involved in and kind of how we work together. Midwest Gen obviously pulling and dealing with the permitting issues. They procured and installed the boiler port tubes, managed the commissioning process and acceptance testing, overall integration in terms of working with Gray Corp Sargent Lundy and Fuel Tech, and providing oversight and interface as far as plant personnel. GSL did all the installation engineering for the SNCR equipment and did the balance of plant engineering, including some various roadways that needed to be constructed, dealt with those water systems and the installation of those issues, site access, and provided all the installation materials, labor, and also a big component was that they were responsible for the overall master schedule. In terms of the team approach, there was a lot. I'll show you a slide in a minute. A lot of these units were pretty close coupled in terms of what we had to do in terms of overlaps of schedules. So that really pushed us towards a team approach, and we did a lot of joint design review meetings. That use of the Gray Corp Sargent Lundy master schedule was extremely helpful in terms of kind of keeping the communications oriented between the parties. We had weekly team meetings, site meetings at the plant, not only at the kickoff of the particular project is to kind of identify the scope and equipment locations, but also to kind of deal with those port tube locations and interferences. Typically when we find out where we want to put something, well, maybe there's something that needs us to move over 6 inches or 8 inches down or whatever the case may be, but that we took that and made that very interactive to keep the project moving. And then monthly project meetings at each plant during the execution phase were held. And then we had ongoing quarterly meetings with the executive teams to make sure that we were all on the same page in terms of communications, and safety and quality were really paramount through this process. You're not really supposed to be able to see all the details on that just because it is a complex schedule. Powerton, Joliet, Crawford, and Will County are the units going kind of down the page there. And based upon the overlapping requirements not only for construction and port tube installation, a lot of dynamics involved with the team in terms of pulling this fleet-wide compliance into place. Couple of pictures here, some field erected urea storage tanks. I mentioned that a lot of our tanks are fiberglass. These are field erected 350,000 gallon storage tanks at Powerton 5 and 6. And those were installed right on schedule. I won't talk too much about the equipment, but I mentioned the zone metering module. Allows us to do independent zones, so we can be injecting on level 2 and 3 at the same time. It's not an either-or proposition. So as we're chasing that temperature window, that independent control gives us ultimate flexibility to make sure that we're meeting the right process conditions. Dilution water pressure control modules. I will say, as it relates to Fuel Tech construction of our equipment, everything is stainless. I mean, we've had systems out there in the field 20 years, and the only thing they're changing is injector tips, and things still keep running. And in some ways, my aftermarket guy wishes there were a little more obsolescence planned into it, but that's not really the case. Same thing with the wall injector distribution module. It allows us to meter and control and monitor the flow to each individual injector, and that can be very important in the field when you're going through optimization and tuning process as you're trying to finely tune that performance. Standard SNCR wall injector. This is an oxide injector with air atomizing. Essentially, it's very simple in terms of removal and checking injector tips, checking sprays, and then putting the injector back into service. And you can see this is from within the unit, standard SNCR wall injector in operation. You can see we are out past the edge of the tubes, making sure there is no blowback, no impingement issues, and we continue to monitor that with ongoing operations. As it relates to the project challenges, resource constraints, as I mentioned on these multiple projects, was an ongoing issue. Required a lot of juggling between Midwest Gen and GSL as it relates to labor, and also Fuel Tech as it relates to some of our field people was more the issue. The CO levels were definitely an issue on a couple of the units, and one of the things that we did was essentially, I talked about before, combustion tuning for CO improvements and sometimes CO reductions, and that actually raising the NOx level a little bit, but we kind of knew what we were getting into as it relates to providing the overall system guarantees. And we made some changes to the injector configuration in terms of some changes in the injector tips, but also some of the angles as far as the injectors in terms of their insertion. We came up with some new configurations for injection, flexible hose for the RRI at 2600 plus degrees in terms of that environment. It's pretty difficult relative to what you're trying to do in that area of the unit, and so kind of forced some design flexibility and some design innovation that we were able to apply with the RRI injectors and also the HERT. The port installation priorities were kind of interesting. Of course, putting in the ports and the outages for the ports didn't follow anything in terms of which units had to have equipment. Some of the last units to go be installed were actually the first ones to have ports put in. So it required us to essentially do all of our modeling and get all of those final design details done and get ports installed, and then the units would kind of go back into the queue for when the equipment would actually be provided and installed. And I think the documentation control was an essential and a key with the multiple units and overlapping schedules. This is just an overview by site of what we're talking about in terms of quantities of equipment at the various stations. 92 HERT injectors, 32 RRI at Powerton, and then a combination of HERT, RRI, and NOx out injectors at the other stations. And right there we've kind of referenced megawatt size and also the amount of urea storage that we provided. Midwest Gen, going through this process, like I said, they were in the 0.2 to 0.25 range. They did do some additional optimization on their burners. They have been pretty specific relative to not wanting to talk too much about the details of each individual unit. But when you look at RRI SNCRs, like I said, a typical unit being 60%, we're doing better than that at the Powerton units. But that allowed us to essentially get down to that 0.11 fleet-wide average. We generated significant savings that were shared between Fuel Tech and Midwest Gen. When you look at the capital costs, comparing it to what they were looking at Powerton, we were less than 30% of that SCR option. My view is probably significantly less than that. But from their perspective, SNCR is not always going to fit for every unit in terms of flagship, type of operation. But when you have a fleet-wide situation and some capital constraints in an environment right now where people are out there with a lot of MATS requirements, a lot of issues that they're dealing with, when it comes to NOx requirements, SNCR can be a very effective technology to apply. Crawford and Fisk, we were making the .11 when those units were in operation, but those units have obviously been decommissioned, if you guys are following any of that. And Midwest Gen, we continue to work with them as they are optimizing the system and operational issues to continue to reduce the urea consumption, which is really at the heart of what those operating costs are. So with that, I'll take any questions if anybody has any. Nope. Okay. Thank you.
Thanks, Kevin. That was kind of a nice blast from the past for me, because I was the guy that negotiated that agreement with Midwest Gen back in '06, so that was kind of fun to see what's happened with it since then. And the interesting part of that was not negotiating specific equipment, but negotiating a number that they could hit and finding different solutions, as I talked about earlier, that none of us had really thought of. So that's great. And here all this time I thought Rich Reagent was just a character on Days of Our Lives. So, but appreciate your presentation, Kevin. We're going to move from SNCR Technology to the future of CCP, recycling, how regulations change the game. Obviously an important subject, and one that we've been, that I know we talked about a little bit at some of our roundtables, and what the regulations are going to mean for this. So to take us through this will be Thomas Adams. Thomas is the Executive Director of the American Coal Ash Association. So we look forward to Thomas's presentation. There he is. Please welcome Tom.
Thank you. I appreciate the opportunity to spend a few minutes this morning talking about beneficial use and where things are at today and where we see them going. As we start the discussion today, I wanted to take a step back and see where we've been with beneficial use. Let's see. Do a little technology here. Okay, the American Coal Ash Association is in the used coal business. We've been around since 1968, founded as the National Ash Association. We're currently headquartered in the Farmington Hills, Michigan area, which is just outside of Detroit. We're a very small organization, about 160 members, including utilities. Some of the very largest utilities in the country are members, and we have the ash marketing companies and all the others that you see listed there. The ones we don't have, interestingly, are coal companies, and we need to change that because part of what we do is clean up after the coal companies, so we need to have them in. Many of you in this room are members, and we certainly appreciate that. Our primary products, as you well know, are fly ash, bottom ash, boiler slag, and FGD materials. Also, there's a very nice market for cenospheres, and basically anything that's left behind after we burn coal, we will find a market for if it meets the requirements of our mission. Our mission is to encourage beneficial use, but we have 4 criteria, including protection of the environment. The materials have to be technically appropriate for the intended use. They have to be commercially competitive, and they also need to help contribute to sustainability. Those are the 4 measures that we use for describing a beneficial use. In terms of topics we want to cover here in the few minutes we have today, we'll take a look back at beneficial use of coal combustion products, and of course everybody seems to have their own term for these materials. The feds like coal combustion residuals, some folks like coal combustion waste, some folks like coal combustion byproducts. We choose to use coal combustion products because we think that it accurately describes the value of these materials. If you look at the recycling markets, the estimate of the direct impact on the U.S. economy is somewhere in the $9 to $10 billion range per year, with direct and indirect impacts estimated by EPA as much as $23 billion a year. In Washington, a rounding error, but for the rest of us, it's real money. We want to take a look at recycling today and why we're in the condition that we're in today. And then we'll kind of take a look at where we think we're going, depending on the outcome of the current regulatory efforts in Washington. In terms of some data points to give us some reference, in 1968 we began in our first year surveying production and use of coal combustion products. We're currently in the process of conducting the 2012 survey right now. It's very important that we get data back from the industry. We contact all the power plants that are burning coal, ask them to submit some forms that we provide to them, and we're currently getting responses from about 75% of the power plants that are out there, and the vast majority of the generation is reporting to this survey, and that's a very important thing because this particular report is used quite a bit by different agencies, including EPA. It provides some unique information that's not available anywhere else. And currently, EPA, interestingly, would like to stop using this report because it's embarrassing them in terms of the support for beneficial use that they're not providing anymore. That report will take a look at 14 categories of use, including things like cement and concrete products, structural fills, gypsum panel products, agriculture, these sorts of things, and 8 different types of CCPs are analyzed in this report. It's available on our website, so if you want to take a look at the 2011 report or previous reports, they're certainly available there. In terms of recent history, we take a step back about 20 years or so and take a look at beneficial use in the 1990s was running somewhere in the 20 to 30% range. Through the 90s, it just bounced around in that particular range, some of it related to the economy, but some of it certainly related to the potential regulation of the material. At the beginning of this century, the recycling rate was 29.5%. It peaked at 44.5% in 2008. There's kind of a nice bump there between 2000 and 2008 of 50% rate increase, but also, more importantly, if you look at the tonnage, the tonnage tells you a more important factor in that the coal burn during that period of time increased dramatically, as all of you know. So it was not only a nice increase in rate, it was an increase in the real tonnage. So that's really an important fact. Since 2009, beneficial use has been flat at about 43%. And we've asked the question, why? Well, certainly the big issue is regulatory certainty. EPA, as you know, when Lisa Jackson became the administrator in 2009, committed to coming out with regulations regarding coal combustion products. And they did deliver a rule in late 2009 and went over to the Office of Management and Budget. It stayed over there for about 6 months while they corrected EPA's homework and sent it back to them. And then EPA, as many of you know, issued what they called a rule. It actually was just more of a buffet of proposals. A lot of questions. If we do this, well, how about that? And it really was no rule to comment on, which seems to be kind of the tactic they take these days. They don't really give you anything like the ELG announcement. There are 8 options, as I understand. We're not in the water business, but I understand there's 8 options to look at there. There's nothing substantial to comment on a proposal. And that's what happened in our case as well. They came out with 2 or 3 options. If we look at the history of the regulatory efforts at EPA, they've been trying to write a regulation now for over 30 years, and they can't do it. They can't do it because of the way the Resource Conservation Recovery Act is written. Certainly, if you look at enforcement of Subtitle D rules, Subtitle D being non-hazardous materials, they rely on citizen suits, which really is no enforcement tactic at all. Of course, Subtitle C is enforced by EPA, and that's why that's their preferred route in this particular issue, is they control the enforcement activities, not the states, and they certainly don't trust the states to do that. If you look back at 1976, the Resource Conservation Recovery Act came along. Some things were corrected in 1980 in the Bevel Amendment. The EPA was directed to provide information to Congress, which they did in a couple of reports to Congress. In 1993, under President Clinton and Carol Browner, there was a determination made that ash did not warrant management as a hazardous waste. A final determination, again under President Clinton and Carol Browner, in the year 2000 came to the same conclusion, that ash did not warrant management as hazardous waste. Of course, today we find out that final determination of the year 2000, it was not final at all. and EPA would like to reverse that if they had their own way. So we have this climate right now of regulatory uncertainty, and we don't know where we're going to go necessarily with the future of regulation of disposal of ash, and that certainly affects our ability to recycle this material. And how it affects different groups is very interesting. From the generator standpoint, obviously utilities don't want to put a material into markets that exposes them to further liability. Since 2009, when the announcement was made that EPA would be creating regulations that would affect disposal and beneficial use, a lot of utilities have said, okay, we got existing liability for products we put out there for decades with no damage cases, with no liability problems, but we're not going to put additional sources and additional materials into markets until we know what's going on. So we've had a lot of situations where we could have brought more material to beneficial use, but utilities have said until we have regulatory certainty, we're not going to go in that direction. So the generators have had to look at that closely, and obviously, if you're in a situation where you have some tort exposure, those costs in many cases are not recoverable in rate structures, whereas disposal costs are. So if you're a utility that's looking at this, you say, well, on the one hand, if I can recover all of my disposal costs by sending all my ash to disposal versus sending it into recycling markets where I have an exposure to tort activity, the logical thing to do is to go to 100% disposal. So regulatory uncertainty is affecting the materials that are available. Certainly the marketers and the competitors to those marketers are being affected. The marketers have less material available to take to markets, particularly where where there's high demand, like fly ash markets. The competitors to those marketers are using the potential hazardous waste label as an opportunity to attack products. For example, we've had situations where bottom ash being used for masonry units, concrete masonry units, has been attacked by folks that compete with lightweight aggregates. The folks that are marketing lightweight aggregates in a couple places in the country have said, does your concrete block contain hazardous waste? Well, it doesn't if you use our material. And so they put out ads with a skull and crossbones and all these sorts of things trying to infer that the use of bottom ash in concrete masonry units is hazardous to a homeowner. Certainly, those things pop up when homeowners look at a material, and they have an implication that there's hazardous waste in it. No one's going to take that material and put it into the carpet in their homes, the gypsum in the wallboard, the concrete in the foundation and slabs, or boiler slag that's used in roofing shingles. Folks don't want hazardous waste around their homes. Certainly users, contractors that take the material, put it into ready-mix concrete or place concrete and that kind of thing, they don't want to be associated with handling a material that could be characterized as hazardous waste, not only for the end result liability that they're exposing themselves to, but certainly from a workers' compensation standpoint. We've heard from contractors that said, if this material is described as hazardous waste, I can't have it on my property and my concrete trucks. My contractors won't buy it from me and have it on their job sites. We're not going to expose ourselves. Certainly technical organizations have spoken up during this rulemaking effort by EPA and commented to EPA and have told them that if you look, for example, at the building code for structural concrete that comes from the American Concrete Institute, this particular building code is used in all the states here, all 50 states, and it's also used in 29 foreign countries. The American Concrete Institute looked at this situation and they said, we would have to remove fly ash from the building code if you declare the material to be hazardous waste for any reason. And their rationale for that is that, by definition, the building code is there to protect public safety. By definition, you cannot include a material that's considered to be hazardous waste in a building code. So they told EPA that would have to come out, and Lisa Jackson didn't like that particular meeting at all. ASTM International said the same thing to EPA, and EPA responded to them by saying, well, you know, we're not saying it's hazardous, but ASTM said all we're saying is in all these standards, and there's over 500 standards if you look at ASTM documents that contain some reference to coal or coal ash. All these documents will have to contain some kind of a warning to the reader that under certain circumstances this material is considered to be hazardous waste. So we see, and there are other examples as well for the insurance industry. Certainly, professional liability insurance is important to engineers and architects, project owners, contractors. We've seen situations where renewal policies for folks on professional liability have come back with an exclusion that if you put coal ash into a particular project, that project is no longer covered by your professional liability insurance. These things are very scary things when you start throwing around hazardous waste terms without considering all of these things. And for these reasons and more, EPA has painted themselves into the corner with this effort to regulate coal ash. On the one hand, they would like the ability to regulate and enforce disposal requirements. On the other hand, they don't want to affect beneficial use. They've heard from a lot of people on this issue, and they really don't know how to figure this out and write a rule right now that gives themselves the authority that they have only under Subtitle C under current law, and at the same time doesn't damage beneficial use for all of these concerns that we just mentioned and more. In terms of the state regulations, at this point in time, I was kind of disappointed that Jim Rohr was not here yesterday from USWAG to give his perspective on what's going on, because Jim and USWAG and EEI have done a great job of leading a coalition of stakeholders, including the rural electric cooperatives, the American Public Power Association, a lot of groups like ours that are stakeholders for other reasons. They've done a great job of providing leadership on this issue, and we work very closely with them. In this particular issue, we're only involved to the extent that whatever happens in this issue affects our ability to promote recycling. On the disposal side of the discussion, whatever's in disposal regulations is not our concern, it's not our expertise. We certainly get out of the way and defer to EEI when it comes to that. However, just kind of an update as of what's going on right now, EPA continues to work on a rule. As you know, the rule that they proposed in 2010 attracted over 450,000 comments. Now, granted, most of those comments were the kind of the robo postcard that you see so many times where you fill in your name and address and the text is already there and you just hit a send button. But there were over 10,000 comments that had very substantial issues raised to them that EPA has to take a look at and respond to. In our particular case, we had over 13,000 man-hours put into our response to EPA, and we were not the largest responder by any means. If you look at that particular situation, EPA says they're continuing to look at that and continue to respond to these things. They put out one notice of data availability already. There's another one that's pending right now that has to do with the ELG situation. We were told that particular nota is going to come out any time. Of course, they said that a year ago too, so we don't know when that's going to come out. Certainly after that particular notice of data availability comes out, response period, EPA responds to the responses and that kind of thing. We're looking at a timetable which tells us EPA cannot do anything until sometime in 2014 at the earliest. And remember, in this situation, EPA has no deadline. Congress didn't tell them you must have a rule by a certain date. Court didn't tell them you must have a rule by a certain date. They picked up the ball and ran with this on their own. So they have no deadline, and conceivably they could just drop it and not do anything, which is really not good for particularly our situation in the recycling markets. Congress is trying to help for a change. They've made some efforts, and we'll talk a little bit more about that in just a minute, but Congress has looked at this and really come up with some ideas that provide a solution. So I think in terms of looking at the three legs of government, executive, judicial, and congressional, legislative, Congress is probably in number one by quite a ways. There is activity in federal district court on this issue, as some of you may be aware, that has been kind of lingering now for about a year. In Congress specifically, David McKinley, congressman from West Virginia in his second term, has led the effort to resolve the issue. McKinley is a professional engineer. He's had his own design practice in West Virginia for a long time, which he had to resign from in order to run for Congress. It's a significant design firm, about 100 employees, and they've been around for a while. He looked at this issue, and his background includes quite a bit of use of coal combustion products, particularly fly ash, and it just struck him that that this was just an overreach by EPA, and he needed to stop this issue and when it came to the hazardous waste option. In fact, 1 month into his first term in Congress, McKinley introduced a bill which very simply said EPA will not regulate coal ash as a hazardous waste. Of course, nothing can be done that simply in Congress, so they started to work on that bill, and it evolved into something else. McKinley will introduce a bill as soon as next week. It'll be, I think, the 5th or 6th version of a bill that has been introduced in the House. It has, the nice thing about this bill is it's based on a Senate version from last year. When the last McKinley bill went over to the Senate, there were a number of senators that looked at it and said, well, we think we can do something with this, but we need to make some adjustments. They made their adjustments. It's come back around to the House again. McKinley has taken a look at it along with the House Energy and Commerce staff, made some changes, and they will introduce this new version next week. The House has now passed this 4 to 5 times. This will be the 6th time they've passed this particular kind of a bill. The Senate, we had good Senate support last year, and we came very close to passing a bill last year, or the Senate did, in the transportation crisis in terms of transportation funding in June of last year. If you may recall, in June of last year, transportation was going to run out of money, and Congress got together with a conference between the House and Senate and said, what are we going to do about this? And as they negotiated on transportation, 3 amendments were brought to the discussion by the House. One of them was a harbor maintenance and construction bill. Another one was Keystone XL pipeline, and the third one was this particular issue. We got down to within the last few hours of conversation on what was going to happen. A couple people in the Senate brought some new issues to the table, and that just got everything very, very conflicted, and so they pulled all the amendments off the table and just voted on transportation. So in a kind of a football analogy, we got down to the 1-yard line, we couldn't punch it in. A lot of disappointment, a lot of folks felt very bad about that, and the Senate went back to work and created a new version of the bill, reintroduced it. There were some efforts to do something in lame duck, but we were not successful there. So that combined with changes in the Senate, of course we have to have 61 votes there to get this through, combined with the changes in the Senate because of those who retired, those who were retired by the voters, and those who have gotten a little wobbly on this issue. For example, in Missouri, Senator McCaskill was a supporter of the Senate bill last year. However, since she's been reelected and has 5.5 years to figure out what she's going to do next reelection, she's become a little wobbly on this issue, and we need to go back and re-educate folks in her office. But we do have obstacles in the Senate, but there's optimism that that's going to be overcome. In terms of support for the McKinley solution, and this bill is unique. If you think about what happened in 2010, there was a big change in the House. And a lot of things that came out of the House when the Republicans took over in 2010 in terms of EPA bills were attack bills. You will not do this. We won't fund that. It was just like one thing after another to get in the face of EPA. This bill was different. The McKinley bill that came out in 2010 was a solution to an issue which most people on both sides of the aisle agree needs to be addressed. Many of the states do a wonderful job with disposal. There are a few that don't. So in establishing a baseline of standards for disposal seemed like a good thing to do. When the House passed their bills, they passed with significant bipartisan support. When the Senate introduced their particular bill last year, S-3512 was the latest bill they introduced. There were 12 Republicans and 12 Democrats on the bill. So very strong bipartisan support. So this was a bill that provided a solution. It wasn't an attack on EPA. It wasn't anything to be confrontational. So in this particular case, the folks that support McKinley's bill include the recycling industry. Certainly we're in favor of it because it accomplishes our one and only goal, and that's to get hazardous waste rules off the table. That's our sole interest at the American Coal Ash Association. Once that's done, we're out of town and we'll move on to other things. The regulators like it. The House Energy and Commerce Committee has been working closely with the Environmental Council of the states and SWAMO, the solid waste managers. They're happy with the format. Certainly generators through Edison Electric Institute, the Rural Electric Cooperatives, American Public Power Association, USWAG, they've been included in the conversation and have been helping to create a bill that makes sense and also is something that can give protections immediately. If you look at the hazardous waste option, if EPA for some reason was successful in coming out with a hazardous waste bill or proposal, you'd be looking at a time period of somewhere between 5 and 10 years before that would actually be in place nationally to provide protection of human health and the environment. Probably more in the 7 to 10 year range by the time you would have all the litigation that would accompany this and these sorts of things. The particular bill that McKinley is offering, according to the Environmental Council of the States, that particular program could be up and running within 2 years. So if you're really concerned about protection of human health and the environment, certainly 2 years looks a lot better than 7 to 10. The opposition to McKinley is certainly coming out of the anti-coal crowd. The Sierra Club's Beyond Coal initiative is well known to everybody. There's a lot of other groups, including Earth Justice, Environmental Integrity Project, and on and on and on, that are opposed to the McKinley bill because they feel that hazardous waste rules are needed. Certainly marketers of competing products, as I mentioned earlier, we have these folks that compete with folks that market the bottom ash into concrete masonry units. We had another example of guys that do recycled glass as grit for roofing shingles. They tried to claim that boiler slag was a hazardous waste and shouldn't be used in roofing shingles. These kinds of companies are certainly promoting hazardous waste rules for coal ash so that they can promote their own products. And finally, marketers of other fuels. If you have another fuel that can be used, and obviously the natural gas is the choice, is the number one alternate fuel, they're going to be favoring hazardous waste rules as well. So we have those three groups: the anti-coal activists, the marketers of competing products, and the marketers of other fuels, opposed to McKinley, and pretty much everybody else in the Western Hemisphere is supporting McKinley. So that's kind of where we're at with regulations. We certainly, I didn't touch on the federal court situation. There was a suit filed in 2012 by 11 environmental groups claiming that EPA had not done their job under RCRA to review and revise regulations every 3 years, particularly as they related to coal combustion products. And therefore, they wanted the court to set a date for a regulation. They wanted a regulation done in 6 months. When we saw that particular suit come out, we got very nervous that there was a sue and settle deal that had been put in place. So two of our largest members, Headwaters Resources and Boral Materials, filed suit on the same basis and joined all the environmental people at the plaintiff's table, which was kind of an interesting picture. And EPA has responded by saying that they couldn't possibly get a rule done before the end of 2013. USWAG has joined as a intervener, as well as the National Mining Association. This particular suit is not real high on the agenda of the judge handling it in the federal district court. He's postponed 2 or 3 hearings already. The next hearing is set for July 26th. And in this particular case, again, the environmentalists want a date for a final rule from EPA set by the judge. The marketers just want EPA to declare immediately whether they're going to regulate as Subtitle C or Subtitle D materials. So that's where the lawsuit is. So we've covered all 3 branches of the government there. In terms of recycling for the future, certainly we have challenges and opportunities. Our first challenge will be to handle damage from EPA's regulatory efforts. We have owners out there who have doubts now about whether ash is safe. And if you look at examples such as the Los Angeles Unified School District, they've prohibited the use of ash until EPA provides regulatory certainty. Same thing with New York Public Schools, Anne Arundel County in Maryland, the Arkansas Department of Transportation. We can go on and on with owners who have said, we're really not sure what's going on, whether these materials are safe or not, and we have to go back out into the marketplace and reassure people that these materials are safe and can be used effectively. Certainly changes in material characteristics. We've heard a lot about that yesterday and today. The ashes are changing. And do we have the same ash that we think we've had before? We have to do a lot of testing and a lot of analysis to see just exactly what these materials are. And of course, these are arguments being used by environmental activists too. They're saying, yes, in the past these materials have passed tests like T-clip and all this other kind of thing, but these materials are different now. We're injecting all these new materials and we have multiple processes going on in our power plant. We don't know what we have and we have to test it and we have to be very careful. So the changes in material characteristics are presenting big challenges. Certainly changes in quantities of material available. If you look at fly ash demand is just growing tremendously in particular areas of the country where we're seeing prices for fly ash equal and exceed the prices of Portland cement. Just amazing to see in places because of the shortage of material in particular markets. And certainly changes in logistics. Fly ash has been so readily available in many parts of the country where it was readily available. Trucking costs and transportation costs were really not a big factor. Now they're getting to be a huge factor. So those are some of the challenges that the market's going to have to deal with. But certainly we have opportunities as well. Demand, as I mentioned, is increasing for some CCPs, particularly fly ash in concrete. It's interesting that the EPA, while they're struggling to come up with a regulation that doesn't affect beneficial use, they also, if you look at other federal agencies, whether it be agriculture, defense, energy, commerce, you can go right through the whole list, they're all trying to find ways to use more ash. So the EPA appears to be kind of a lone ranger in that particular interest. Research is showing more benefits from using ash. Certainly we're seeing things like the USDA has a risk assessment, which they've been doing for a number of years now in cooperation with EPA. They're showing great results in agriculture, no detrimental benefits from using FGD in agriculture, and yet we can't get that out of the USDA because it is a cooperative effort. They have to have sign-off from EPA. EPA says it's USDA's fault. USDA says it's EPA's fault. So as a result, we have a tremendous piece of information which could really help those companies that are marketing FGD in agricultural markets with great success where they're doing it. And we need that, but then there are other research things going on. Many of you are familiar that there's a new protocol for analyzing leaching out of Vanderbilt University. We had a report come out of there late last year that gave very good results in terms of analyzing leaching from concrete structures using this new protocol. It showed great results and just reinforced the idea that there is no leaching problem, and we can certainly demonstrate great enhanced durability in concrete by using fly ash. Certainly technologies are evolving for beneficiating ash. Unfortunately, this is one of the groups that's really suffering right now under this EPA regulatory uncertainty that we have. If you think about it for a second, if you have a recycling technology and you go to a utility and say, here's what I can do for you, and I can make your ash much more valuable to the marketplace, but it's going to cost $10, $20, $30 million to put into a unit, there's no utility that's going to invest in your technology as long as there's a possibility that you might be dealing with hazardous waste rules. So our members that are in those markets are basically frozen out of the United States market. They have to look offshore to try and find places to sell their technologies. They're hanging on by their fingernails. But there continues to be advances in those areas, and certainly as we look at these changes in the materials that are happening out there, whether it be in terms of carbon injection, which affects the ability to use some of that ash and concrete and these sorts of things, the technologies are coming along to handle that stuff, and it's going to be an interesting ride over the next several years to see how those two things go step by step to solve the problems. And certainly the hazardous waste designation has crippled recycling, closure of plants. I know every time you pick up a paper and you see Sierra Club saying, look, we closed another one, they never seem to report the fact that perhaps this was a small power plant that should have closed 20 years ago, but has been kept open and it's continuing to produce material and electricity and that kind of thing. Certainly closure of some of those traditional plants that have served markets is a challenge. Again, material characteristics are a challenge in some of the traditional markets. and logistics are going to change the economics of using ash. But what we see in terms of particular markets, for example, where departments of transportation are involved, they need this material to overcome some of the problems they have with questionable materials that they're using in concrete structures. They don't have a choice. They got to figure out how to do it, and the best option for overcoming aggressive aggregates in terms of alkali silica reactivity is fly ash. So that market demand is continuing to grow as we run out of good quality aggregates and we're having to use more marginal materials. High volume fly ash applications are growing rapidly, and certainly fly ash is a great contributor to those folks that are interested in sustainability concerns. Research is showing more benefits. As I mentioned, the leaf testing down at Vanderbilt shows some promise, and FGD in agriculture is another example. And beneficiation technologies are coming along, as I mentioned. Ash recovery, I think, is something that a lot of people are looking at very, very closely. Ash that's in disposal, and we have millions and millions of tons out there that's in disposal right now. Some of it has been disposed, commingled with lots of other things, and is unusable, but there are examples out there where we've been able to identify sources that could be brought back into the market, could be reprocessed and brought back to market, even in some cases in ponds. So ash recovery is something that folks are looking at very closely to satisfy market demand. In conclusion, we have one of the great recycling stories of our time with coal combustion products, and we ought to be proud of what's been done. We can do a lot more. Again, we're at 43% right now. EPA has said that they would like to see us at 50% in the year 2015. They actually said the same thing a few years ago about 2012, and before this whole business started in 2009. But again, we have one of the great stories of our time in terms of environmental success. There's no doubt that EPA efforts to regulate coal ash disposal have crippled recycling for now. They've got us stalled. The markets want more products, and technology is coming along to answer our challenges. In terms of resources, here's some websites you can take a look at. Our website is listed first there. Citizens for Recycling First is a separate environmentally interesting group that it speaks to recycling of coal ash. Certainly USWAG has a very good website and lists all the letters. You'd be interested in taking a look at the inventory of letters from folks that went to EPA on this particular issue. Then you get a feel for how broad the support is for protecting beneficial use. Then some of our members, like Separation Technologies, have their own site. You have to be careful when you're dealing with their website. It's smartash.info. So you have to be very careful with that. And with that, I'd be happy to answer a question or two. Okay, thank you.
Thanks, Tom. I know when we got involved in that issue from a state perspective, and we'd had some issues with some of the ponds and some of the storage of it here, and so we had our own regulations for that. But then we joined in with, I think it was pretty much unanimous of all of the state regulatory agencies working through ECOS and SWAMO, and actually sent in comments saying that we thought Subtitle D made sense and let the states do the regulation of it, because we thought that had been a pretty good system working. One of the interesting points too is that if it were to be declared Subtitle C in a hazardous waste, in addition to all the things that Tom pointed out, there's absolutely no place to put all of that material. And just imagine, if you will, I think about it as a former environmental regulator, imagine trying to site lots of new hazardous waste storage facilities in your hometown, and just think how that one goes over. So obviously a lot of issues that are tied up in it. So thanks for your presentation. Talking about technologies and some of the different technologies that are being used, and we're going to move now toward full-scale plant trials of non-carbon mercury capture reagent through Novinda. And again, as we talked about different, we started to talk about ways where people go into this with one set of assumptions about the products that can be used or the different technologies that have to be used, and very often find their engineers working on it, lots of companies working on different solutions, and very often find different ways to try to attack some of these issues. So standing between you and lunch, and I know he's up to it, is the Vice President for Product Management for Novinda. Jim, say your last name for me. Butz. Jim Butz, the Vice President of Project Management, Novinda. Jim?
There we go. All right. Thank you. Yeah, I'm here to offer a technology hors d'oeuvre before lunch, so we'll get through this and we can get off to the more delicious sustenance. Earlier in the conference, both Bruce Kaiser and John Lemkuhler provided a great primer on the fundamentals of mercury capture. So I'm going to not cover any of that, but I am going to talk about a particular option for mercury control, and that is Novinda's non-carbon reagent product. Start with a little bit of an overview of the company. We are headquartered in Denver, Colorado. It's a venture-funded corporation, and in the past 6 months, we've doubled our headcount. So we are in the process of moving very aggressively into full-scale trials of our material. In fact, we have tested in 25 plants in 2012, and we've got something on the order of 30 on the schedule for this year. We're already well into that. The product itself is evolving. We are now on our second generation product, and I'll talk about the improvements that we've seen in performance between first and second generation. In the past 6 months, we've filed for 5 additional patents, so our R&D effort is up and running. We have expanded our product roadmap. We're looking at other applications of our technology. The second generation material, as I mentioned, has been rolled out, and we've seen a 43% improvement in performance with that material. And we have also begun significant discussions with some of the equipment suppliers to help come up with design design requirements and specifications for injection systems to handle our material as well as activated carbon. We think versatility in those injection systems is something that will really benefit utilities so that they can take advantage of whichever materials work best in their particular installations. As you know, power plants are often described as similar to snowflakes that no two are exactly alike, and there are differences that can be significant in the performance of materials. We have also, as I mentioned, had an extensive field application testing activity going on. In fact, we have tested or are scheduled to test in plants that represent 65% of the coal generation in the United States. We are working on an international strategy, and we have 4 customer contracts that are actually in legal negotiation. I believe one of those was signed this week, so we are in the market. Talk a little bit about the product. It is a non-carbon mineral-based reagent. Our mineral base is bentonite. We then amend that with a actual chemical that serves as the reaction chemical for the mercury capture. It is a metal sulfide, and the reaction product then is mercuric sulfide, which is a very insoluble and stable form of mercury. This is a little bit different than powdered activated carbon in that that is primarily a sorption mechanism. Our material has been shown in tests both in the laboratory and in the field to be a powerful oxidizer, so we can eliminate the need for additional chemicals added to the coal or other places in the flue gas train to oxidize the mercury. We do a great job of oxidizing to Hg+2 forms in and of itself in the material. The material has also been shown to lower the resistivity of PRB fly ashes. This can result in improved performance of ESPs. And finally, there are a few physical differences between amended silicates and powdered activated carbons, a chief one being the fact that we have a bulk density that is between about 40 and 45 pounds per cubic foot versus about 30 pounds per cubic foot for activated carbon. And our particle size is very similar to what you'll see for activated carbons, and for that matter, for fly ash, we have a DV50 between 10 and 15 microns. Perhaps one of the most significant features of the material is that it does preserve the beneficial use of fly ash as well as gypsum. We've taken samples from many of our field trials and submitted those to a variety of fly ash vendors. And each and every test we've run with these materials show that we pass with flying colors all the tests that are used to determine if a material is suitable for use as a cement replacement. We've shown mercury capture greater than 90%, so easily meeting the MATS requirements, and I'll show you some of that data as we get into the specifics of the field tests. The material has been shown to be pretty SO3 tolerant. One of the tests that I'll show you today had an SO3 concentration of about 20 ppm at the injection location, and we were able to very effectively capture mercury at that location. The material is non-flammable. Our pricing is equivalent to that of brominated carbon. We're very excited that last fall we brought online our 20 million pound per year production facility, so that is up and running, and we are able to deliver quantities to power plants in bulk via rail or pneumatic truck, or for field tests we have the ability also to deliver in super sacks. This is some data. We've been working with the folks at Stanford in an entrained flow reactor to do some laboratory testing on SO3 tolerance, and the data is shown on this graph. We've got a relative mercury capture on the vertical axis, SO3 concentration on the horizontal axis, and as you can see, between about 5 and 40 ppm SO3, we have a very flat performance. The increased SO3 does not appear to affect the ability of the amended silicates to capture mercury. Concrete compatibility, this is some data from some tests that have been run in the past. What you see here over on the right, or on the left, is a graph of air entrainment dosage versus the actual air entrained in the concrete. The two curves here that virtually overlay each other are a neat fly ash sample and then a fly ash sample from the same plant after injection of amended silicates. And you can see that the amended silicates had absolutely no influence on the ability of the fly ash to work as a replacement for Portland cement. We also, in this particular test, ran some activated carbon, and so the second graph over on the right side shows the effect that that activated carbon addition had on the air entrainment as a function of the dosage of the agent. Certainly that activated carbon takes up some of that air entraining agent, and until you start to saturate the carbon, you don't see any increase in air entrained as a function of an increase in air entraining agent. The graph on the right side illustrates the ability of the amended silicates material blended with the activated carbon to meet requirements for concrete strength. The blue is the amended silicates plus fly ash, and the white is fly ash neat. And you can see that at 7, 28, and 56 days of cure time, we have virtually identical concrete strength, so no impact there. We've, as I mentioned, have sampled from most of our tests and had those samples analyzed by the array of organizations you see here, several of the cement manufacturers, also several of the fly ash marketers, Boral and Headwaters. In every instance that we've run these tests, the amended silicates material combined with fly ash has passed and shown consistent results that confirm the ability to be used as a cement replacement. Let's get into the field test results. The first field trial I'm going to talk about was run last summer at Santee Cooper's Wynya Station. That particular configuration looks like this. We've got the boiler. Coming out of the boiler, the flow separates into two trains. Train A and Train B is labeled on this schematic. The plant is equipped with SCRs, followed by the air heater, an electrostatic precipitator for particulate capture, and then wet scrubber modules, one on each train. We instrumented this particular trial very heavily, as you can see. We installed Mercury SEMS at the outlet of the wet scrubbers. We also installed Mercury SEMS at the inlet of the wet scrubbers so that we could characterize the mercury capture that was happening due to the amended silicates injection across that ESP. And finally, we installed a fifth SEMS downstream of the SCR but upstream of injection locations. The test was divided into two sections. We spent a few days at the front end investigating in a parametric trial a couple of items including injection location and injection rates. Because we had done some pre-test characterization at this site and found that we had about 20 parts per million SO3, we included the option of injecting hydrated lime. So ports were installed for hydrated lime injection upstream of the locations for amended silicates. We, in the parametric testing, evaluated injection of amended silicates upstream of the air heater and also downstream of the air heater, upstream of the ESP. And in that parametric testing found that we had considerably better performance of the amended silicates at that upstream air heater injection location. We did do some pre-trial characterization, and some of that data is shown on this slide. If you look on the left-hand side, you'll see we're measuring mercury here in pounds per trillion BTU. The first bar is the mercury that we've measured at the outlet of the SCR, so that's our upstream location. And the color coding shows you the speciation of the mercury. So you can see the combination of having a bituminous coal and an SCR meant that over 90% of the mercury at this site is oxidized. We then made a similar measurement at the FGD inlet. So now we're looking downstream of the ESP. And again, you can see that we maintain that high level of oxidation. The difference in these two samples is the actual capture across the ESP from the native fly ash, and you can see it's pretty small. That's what this stacked bar over here represents, is the source of capture. So this is the sum of the differences in these bars here. The final bar over here is what we measured at the stack, and as you would expect downstream of a wet FGD, the wet FGD is capturing almost all of this oxidized mercury. So primarily elemental mercury at the FGD. And interestingly enough, in this case, you'll see that without any controls whatsoever, this plant on this date was meeting the MATS rule. You'll see that that wasn't the case under all conditions. And so this stacked bar over here on the right is a presentation scheme we're going to use in some of the other data here. Green, ESP capture; red, FGD capture; blue, the actual emissions up the stack. We also, as I mentioned, measured SO3 at that upstream location, and you can see that we had about 20 ppm at that SCR outlet. At the ESP inlet downstream of the air heater, you see we're down about a couple of ppm, so that there is significant SO3 removal across the air heater due to condensation of SO3 on the fly ash as it moved through. The net result of this was that a decision was made that we wanted to at least evaluate the use of hydrated lime and its impact on the performance of the amended silicates material. This is a graph that shows the SEMS data at that FGD outlet location. So this is a typical result. A couple of things to note here. We've got mercury on the vertical scale here. We've got plant load on the vertical scale on the far side. Green is the plant load. So you can see that this plant was being cycled daily. About 10 o'clock in the evening, they would drop load, and about 6 or 7 a.m., they'd bring load back up. The MATS limit is indicated by the dotted line across at 1.2 pounds per trillion BTU. The shaded area is the period of time in which we injected amended silicates. So this was a continuous injection. This was the second half of our trial after we had run the parametric and decided upon injection rates and injection location. The plant had specifically asked us to be conservative in those rates because one of the concerns they had about the use of amended silicates was whether or not there would be any impact on the gypsum generated in their wet FGDs. This plant sells that gypsum to a wallboard plant next door, and preservation of that salability of the gypsum was a key requirement for the testing. One of the things that is significant to point out on this graph, a couple of things on the actual mercury traces. So we've got red being the total mercury and blue being the elemental mercury, and you can see those two virtually overlay each other. So indeed at the stack, all the mercury we're seeing is elemental. But the interesting thing was that it actually took about 3 to 4 days before we actually reached an equilibrium in the scrubber between a new level of vapor phase mercury that was incoming and the mercury that's in solution in that million gallons of scrubber liquid. So our extended test condition is listed here. We ran for 100 hours of continuous injection at, as I say, a fairly conservative rate on both the amended silicates and the hydrated lime, about 400 pounds an hour on the amended silicates, 500 pounds an hour on the hydrated lime. Then we reduced the amended silicates injection rate. We dropped it back to 220 pounds an hour, continued the lime, and finally we ran for most of a day with just the amended silicates and the hydrated lime turned off. So here's the 100-hour continuous result. And again, you see the, oops, let's back up, there we go. You see this pre-trial characterization. When we set up to run the actual trial, we had about a 4-hour window on the first day where the SEMS had been installed and were operating well, and before we had completed installation of the injection system. So we were able to run a 4-hour baseline on that date. Interestingly enough, we saw a significant shift in the amount of mercury capture that was happening due to the native fly ash. That increased from about 10% here to maybe about 40% or so in this baseline. Again, the majority of the mercury capture is happening in the wet FGD. And in this case, you can see that the blue line stack emission, we were actually exceeding the MATS limit on this day. So I think this reflects something that I know other investigators have talked about. I know specifically the guys at Southern Company have mentioned that often their wet FGD systems will, just with their capture of oxidized mercury, be able to meet MATS, but it's not 100%. It may be 60 or 70% of the time they can meet MATS. Things like load changes or cold changes can cause upsets that cause MATS exceedances at the stack, and so what they're looking for, and especially what the folks at Santee Cooper were looking for, was an active knob, something they can implement that will help them in those cases where they're not being able to meet MATS with their existing wet FGD. How can we actively inject a material that will get us to that MATS level and help us maintain compliance? And finally, then on the right side here, you see the results from our 100-hour tests, and this is averaged over that entire period. Now you see the dramatic shift. What we've done is taken a lot of that mercury capture that was happening in the wet FGD, and now it's happening in the ESP. So that incremental capture here to better than 80% is happening due to the injection of the amended silicates material. And you'll see here also that now we are well below MATS at about 0.5 pound per trillion BTU in terms of emissions. This is a table that presents some of that same data and with some additional numbers here for the other cases. So our pretrial characterization, and then a baseline, and then we had, as I mentioned, that first case, the 100 hours at 400 pounds an hour with 500 pounds an hour of lime. Here's the reduced injection rate for amended silicates with lime, and then amended silicates without the hydrated lime. ESP removal, SCR outlet gives us the incoming vapor phase mercury. So this is what needs to be reduced to less than 1.2 pounds per trillion to meet MATS. This is the removal across the ESP. This is the removal in the wet FGD, and the final column is what's going up the stack. So you can see that throughout the entire extended trial with the injection of the amended silicates, we were able to meet MATS. At the high rate, we were actually down at a half a pound per trillion. We reduced the amended silicates injection rate, maintained the lime, and we shifted a little bit of the capture from that ESP to the wet FGD, but still below MATS. And when we shut off the hydrated lime, again, significant capture in the ESP. We trimmed it in the wet FGD, and stack emissions well below MATS. So, summary for this particular trial: that air heater inlet injection location proved to be the most efficient for us. The lime did provide some product enhancement. For the extended trial, we were at that 400 pounds per hour of amended silicates and 500 pounds per hour of hydrated lime. We were able to show MATS compliance for the entire period of the extended trial. The plant took very extensive samples of the scrubbing liquor and the gypsum and ran tests on that. All those tests came back positive in terms of the gypsum being meeting all the requirements for sale to the wallboard manufacturing plant. So that was a big success in terms of their concern about the potential impact on that. What we did was we shifted the majority of that mercury capture from the wet FGD to the ESP. We gave them a positive knob that they can turn. And one of the interesting findings we saw was that equilibrium in that wet FGD actually requires several days to be established. So I'm going to step into now some PRB coal testing we've done. And specifically, we've looked at several units equipped with dry scrubbing technologies. So in some cases, it's spray dryer absorbers coupled with pulse jet bag houses, and we've also got one plant in this series that includes a cold side ESP and a circulating dry scrubber. This first trial is a 750 megawatt unit equipped with an SCR and spray dryer absorber, pulse jet bag house. And the AS-022 is our first generation material. Our second generation material is called AS-HGX. So this was run early in 2012. So you can see that, and an important note on this unit is that it was load cycled. They were in an area where there's significant wind generation assets, and so as the wind would pick up in the evening, they would drop load on this plant and then pick it back up in the morning. But as you can see, once we started the injection of the amended silicates material, we dropped well below that MATS line, and we stayed there for the entire 3+ weeks of this trial. A couple of interesting notes here. One is that we were at an extremely low injection ratio. We ran about 0.6 of a pound per million cubic feet of flue gas. In fact, this plant is equipped with an automated injection system for mercury sorbents, and we had issues because we were running at such a low rate. We were below their minimum injection ratio, so we had to actually intermittently inject the material. Another location where we've run extensive tests of the material has been Black Hills Energy's Gillette Energy Complex. A number of units there where we have evaluated amended silicates. Reagent 2 is one of their units that's equipped with an SDA and a pulse jet baghouse. Also has an SCR upstream. Results from that unit are shown here for two different products. The blue is our first generation AS-022, and the second, the red is our next generation AS-HGX product. And as you can see, in both cases, once we start injection, very quickly the mercury levels drop below the MATS level and are easily maintained for extended periods of time. When we tested early this year our next-gen product at a lower injection rate, you can see we dropped from 2.2 pounds per million ACF to 1.3 pounds per million ACF. We were able to show better performance at a lower injection rate. Reagent 1 is another unit, very similar to Reagent 2. Again, SCR, SDA, pulse jet baghouse. Now, in this case, we're running our second generation material. And as you can see, typical uncontrolled mercury emissions at this plant between about 7 and 8 pounds per trillion BTU. Once we start injection of the amended silicates, it drops well below the MATS level, and we're able to maintain that. You can see that, again, we had some feed issues because of the low injection rates we were dealing with here. With our first generation product, we needed about 50 pounds an hour to control below MATS, and you can see we were injecting, in this case, at 30 pounds an hour at that same 30 pound an hour rate, and you can see that we were able to maintain mercury at the stack well below that MATS requirement. Neil-Simpson 2 is a unit at that same Black Hills Energy Complex that is equipped with a circulating dry scrubber and a cold side ESP. And again, we did a long-term injection trial at this location. As you can see in the note here, with our old material, we needed about 25 pounds an hour to get sufficient removal to meet MATS. We were injecting at a rate of actually 7.3 pounds an hour, or about 0.3 pounds per million ACF. And as you can see, once we started injection, we were able to maintain stack mercury levels below the MATS level. So we were very excited about this particular series of tests. And again, we had a feed issue here that caused a little bump up. But when we can consistently feed the material, we see very exciting results in dry scrubbed plants. Looking at a cost analysis, we've also run some trials, short-term trials at this particular plant with brominated PAC. And so you can see the results characterized, summarized here. When we injected that brominated PAC with an oxidizing agent on the coal, injecting 50 pounds an hour of the brominated PAC and about 400 ppm of the calcium chloride oxidizing agent, we were able to meet MATS, but at a cost of about $63 an hour. When we looked at brominated PAC alone, it took about 100 pounds an hour to meet the MATS rate, and so we're at about $75. And then with amended silicates, as I noted, we were able to meet that MATS at a 30 pound per hour injection rate, which means we're talking substantial cost savings on the order of 50 to 60% for these units. I mentioned earlier that there are some handling issues that need to be addressed with amended silicates because the physical properties are a little bit different than those of carbon. So one of the things we did was engage Jenneke and Johansson to analyze our material, and they did go ahead and literally determine these 4 specific properties of the material: cohesive strength, wall friction angles, gas permeability, and bulk density. And after analyzing those properties, they put together for us a set of specifications that would allow systems operating with our material to operate in a mass flow configuration as opposed to a funnel flow. which gives a good, reliable, continuous injection opportunity for the material. So we've got two versions of this spec that are certainly available to utilities if they're interested in either looking at what it would take to retrofit existing systems, or if they are in the process of planning and procuring injection systems for mercury control to give them the versatility to use either amended silicates or activated carbon products. Advantages of the amended silicates material: it's an innovative non-carbon mercury control technology. There's nothing else commercially available that does not contain carbon. It's available now in commercial quantities. As I mentioned, we've got a 20 million pound per year production plant that's up and running, so we can supply material for either full-scale plant trials or for long-term supply contracts. We've seen some advantages in terms of SO2 tolerance, certainly in the field up to 20 ppm. In the lab, it looks like that can be extended to perhaps 30 to 40 ppm. The material is compatible with continued sale of fly ash and shows no impact on the continued saleability of gypsum coming out of wet FGD units. The material is non-flammable. We've got data that shows that it's a powerful standalone oxidizer. It improves the capture of high resistivity dusts in cold side ESPs. So if you're firing a PRB coal, there could be some co-benefits of using amended silicates. We've shown that in dry scrub configurations, there is a significant reduction in the feed rates required to meet MATs. The material is cost competitive with brominated PAC, and as another side benefit, the production process is pretty straightforward and doesn't require near the energy of PAC or brominated PAC, and so we have a reduced carbon footprint. And with that, I'll take any questions you may have.
Question I have is, were any tests done at Black Hills looking at PAC and calcium bromide rather than calcium chloride?
No, they had an existing coal additive injection system that was built around calcium chloride, and that's what we used. Yes, sir.
Were all the injection points of the air heater, and was it hot side or cold side?
For the eastern bituminous, the Santee Cooper site, that was upstream of the air heater. All of the injection actually at Black Hills, and even in the other PRB site that I mentioned, were downstream of the air heater, upstream of the SDA. Turns out the SDA, I think, gives us tremendous contact time and mixing. So those are the two things that we believe are significant in getting efficient and effective mercury capture with the material. Because of the fact that it's a chemical reaction, I think it takes a little bit longer than the sorption process with activated carbon.
How extensive is the injection equipment that you need?
It's identical to activated carbon, so similar kinds of costs. Yep, yes.
Pneumatic transfer.
Yes, absolutely. All right, I guess it's lunch.
Thanks, Jim. Time for lunch. It's back where breakfast was this morning. Okay, so be back here at 2 o'clock. Thanks.